So we're going to talk about forces that act at a distance. This is part one of two parts because there's three different forces that act at a distance. The biggest one, the one that we come in most contact with, is gravity, so that's the one we're going to talk about most first. The next video you get will be about the other two. So this is forces that act at a distance, part one, gravity. As a reminder, a force is a push or pull. So what gravity does is gravity is a pull. It pulls you back towards whatever object. So how hard of a pull? There's a formula for calculating the force of gravity. The force is equal to the mass of the object times the gravity constant. The gravity constant changes depending on how big an object is. On Earth, the gravity constant is 9.8 meters per second squared for all objects. What does this mean? That every second an object is falling, it is accelerating, and it's accelerating at a rate of 9.8 meters per second. This does not take into account air resistance. If there was no air resistance, all objects would fall at the same acceleration. They would all fall at 9.8 meters per second squared. For example, if you were to drop a feather and a bowling ball, if there was no air resistance on Earth, they would both accelerate at the same rate. Every second they were falling, they would fall for an additional 9.8 meters per second faster. But because we have air resistance, we know that isn't true. However, if we could somehow drop them in an area where there was no air to resist, on Earth, they would fall at the exact same rate. So what determines the effect of gravity? What determines how strong that pull is or that acceleration towards whatever the object is? Distance is one of the things. The distance. The further you are from an object, the less you feel its gravity. For example, you don't feel the sun's gravity because it is so far away. The sun has a lot of gravity, it has a really strong gravitational pull, but because you are so small and you are so far away from the sun, you don't feel this effect of the sun's gravity on you. The other thing that affects the pull of the gravity is the mass. The bigger an object, the more gravitational force it has. For example, the Earth has a greater gravitational force than the Moon because it is so much bigger. And the Earth and the Moon are both still really big objects, but because the Earth is so much bigger than the Moon, the Earth's gravitational force is much greater than the Moon's gravitational force. So it said that the amount of gravity you have is determined by the mass and the distance. So we all have mass, don't we have gravity? Yes, but mostly no. Yeah, because we have mass, we have gravitational force. However, because we are so small compared to so many things around us, the gravity we have is insignificant. Sure, we might have a decent amount of mass, but the Earth that you are standing on or sitting on, however you are right now, has so much more mass than you, that your mass is so insignificant that the small gravitational field that you might have doesn't even matter because the Earth is so much more powerful around you. So what does gravity actually do to us? The first thing that gravity does is it tells us our weight. It makes our weight. The bigger the planet, the bigger our weight. For example, you could be 112 pounds on Earth or 672 pounds on Jupiter, 6 times that. The smaller the planet, the smaller the weight. For example, if you're 112 pounds on Earth, you'd only be 28 pounds on Mars, just a quarter of that. And the reason for that is because of the size difference. Like it says, the bigger the planet, the bigger the weight, the smaller the planet, the smaller the weight. But your size, both your mass and your volume, so how much space you take up and how much mass there is inside you, don't change. Just how the gravity pulls on your size. Just the strength of that gravity is what changes your weight, but your mass and your volume never ever change.